Hi guys, here in this lecture we are going to discuss precipitation titration. Okay, so here in this lecture we are going to learn introduction, applications and some important methods like Mohr's method, volhard's method and fajan's method. Okay, so we are going to start with definition of precipitation titrations. In simple words, we can define precipitation titration as the titration in which titrant and analyte react to produce precipitation. Okay, right. To make the precipitation titration more successful, we need some requirements. That means we need to look at some requirements of the reaction which is going to examine through precipitation titration. Okay, right. The reaction must be sufficiently rapid, okay, and it should produce a product of reproducible composition with low solubility. Okay, that means the reaction which produce the product should have low solubility and should be precipitate. Okay, and for those reactions a method must exist to locate the endpoint. So we can use the methods like Mohr's method, volhard's method and fajan's method. So here one of the methods should be applicable for that particular reaction, then precipitation titration is more desirable for that particular reaction. Okay, right. Now so we can come across difficulties of precipitation titration. In that the first one we can see precipitation frequently proceeds slowly or starts after some time. Okay, so whenever we look at many precipitation reactions, we can see that precipitation starts slowly or starts after some time. Okay, so that is one of the difficulties we can observe. Right here, many precipitates show a tendency to adsorb. That means so they can make co-precipitates with the titrant which is going to add it to that analyte. Okay, and also we can see some of the indicators may adsorb on the precipitate which is formed during the precipitation titration. So these co-precipitations leads to they causes unable to function to produce or to find the endpoint in those precipitation titrations. Okay, right. Next difficulty we can come across if a precipitate is highly colored. So the precipitate which is produced from that particular reaction, if it is having so high color in it, intense color in it, then visual detection of color change at the endpoint will be very difficult. Okay, for example, if you look at a particular reaction, if it produces white precipitate as the product, then the milky solution may still make location of endpoint will difficult. Okay, so due to all these difficulties, so we can say that precipitation reactions are having limited applications nowadays. Okay, right. Now major applications of precipitation titration. So the important application of precipitation titration is simply to determine silver plus and halide ions in inorganic and organic compounds. Okay, so this is the major application we can see from that precipitation titration. And here titrations with silver nitrate or sometimes called as argentometric titration. So it is important for competitive purpose, just note down. Now silver nitrate is the most widely used and important precipitating agent in determining halogens. Okay, so just take another important point here. Silver nitrate is the important precipitating agent and which is used in the determination of halogens. Okay, right. Next, finding an endpoint in precipitation titration. So here in precipitation titration, there is an abrupt decrease in analyte concentration. At the same time, increase in titrant concentration can be observed at the equivalent point. Okay, so that's why here whenever we take a plot of log analyte concentration or log titrant concentration versus volume of the titrant added, so then it produced S type of curve, titration curve with break, or simply here at the equivalence point, or just we can find endpoint through the indicator. Okay, we can find the endpoint through the break or by the indicator. Okay, right. Next, how to improve rate of precipitation for the particular reactions to get the best results. Okay, so here as we said, the first important desirable requirement is the reaction which is going to examine through the precipitation titration should be sufficiently rapid to produce the product, should have low solubility. Okay, other than that, to improve the rate of precipitation, it is sometimes beneficial to change solvents. Example, by adding alcohol or by just rising the temperature, and also by adding an excess of reagent and back titrating, so we can improve the rate of precipitation. Okay, right. Here the best one here, conductometric or simply amperometric method. So one may be able to take advantage of faster reaction rate at the equivalence point. Okay, right. And next one, the stoichiometry must be exact. Okay, so in direct titration, it is not in general possible to take advantage of beneficial effects of aging on the purity of precipitate. So therefore, it is necessary that under conditions of titration, co-precipitation should be negligible. Okay, so we can see co-precipitation by solid solution formations or foreign ion present in that particular solution. Okay, and adsorption must be considered possible source of error here. Okay, so that's why the nature of the solvent, the pH of the solution, the concentration of reactants, low solubility product of the compound formation during the titration, and the nature and concentration of foreign substances. So we need to consider all of these important factors which are going to make an error. Okay, so that's why, so the stoichiometry of the reaction which is involving in that particular titration should be exact. Okay, that should be exact. Now here next one is we need to look at argentometric titration. So argentometry is derived from a Latin word, so simply called as argentum, which means silver. Okay, the most widely applicable precipitation titrations involve the use of silver nitrate with chloride, bromide, iodide, and thiocyanates. Okay, so since silver is always there, so these precipitation titrations are simply considered as argentometric titrations. Okay, right, and so that's why here we can say these precipitation titrations are limited, because here, so we can see that means by just using these titrations we can find some of the ions only. Okay, right. So here according to endpoint detection method, we have three main procedures like Mohr's method, and next one is Euler's method, and next one is simply Fajan's method. Okay, now just look at Mohr's method, very important. This method utilizes chromate as an indicator. So the question, which indicator is used in Mohr's method? Simply chromate is used as indicator. Okay, this method is applicable in determination of chlorides and bromides, but not applicable for iodides and SCN-2 row halides. Okay, right. Chromate forms a precipitate with silver plus, but this precipitate has a greater solubility than that of silver chloride. That's why silver chloride is formed first, and after all chloride ions consumed, then the next drop, that we call it as the first drop of silver plus in excess will react with the chromate indicator, and which gives reddish precipitate. Okay, so here the titration starts with the making of silver chloride salt precipitate. Okay, and after the formation of, or after the consumption of all the chloride ions, then so the excess, the first drop of silver plus react with chromate to make silver chromate, and which is in reddish color. Okay, so in this method neutral medium should be used, since in alkyl solutions pH is greater than 10 and silver then react with the hydroxide ion to make silver hydroxide. So that's why here neutral method should be used. Okay, and in acidic solutions, chromate will produce HCrO4 minus. So that's why to avoid to make to form silver hydroxide or HCrO4 minus, neutral medium is the desirable medium in Mohrs method. Okay, so the pH of the solution should be kept at 7. So in Mohrs method, the pH of the solution should be kept at 7. Okay, so there is always some error in this method because a dilute chromate solution is used due to the intense color of the indicator. Okay, so this will require additional amount of silver plus for making silver chromate. So this leads to late equivalent point, and to correct this error, we can use or we can determine a blank. Okay, right. And next one. This method relates with greater titration error because it is difficult to observe red color of precipitate over yellow color of indicator here. Okay, right. And so important points in the titration we can observe: before endpoint, addition of silver ions, formation of silver chloride by precipitate. Now the chromate indicator which is present in that solution will give faint yellow color. Okay, at the end point or at the equivalence point, all Cl- ions consumed and excess silver plus react with chromate ion gives slight reddish color. Okay, so after the end point, formation of excess silver, presence of excess silver reacting with chromate to produce silver chromate. That means the concentration of silver chromate increases, and which leads to stronger reddish precipitate. Okay, right. Next, attention needed here in Mohrs method, that is the consumption of indicator is in general 5 into 10 power minus 3 mole per liter. So if the concentration of K2CrO4 indicator is too high, then the end point is observed in advance. So in that case, result is low. If the concentration of indicator is too low, the end point is delayed. So that is result is high. Okay, right, just observe it. And next case, volhard method. So this is an indirect method used for determining the anions that precipitate with silver. So here Cl minus, Br minus and I minus. Okay, so in the first case, Cl minus ion is precipitated by excess standard silver nitrate solution here, which is having known quantity. Okay, so just look at here, formation of silver chloride. The precipitate is isolated and excess silver plus is titrated with standard thiocyanate solution in the presence of iron plus 3. Okay, so after all the silver plus ions have been consumed, the HCN minus reacts with iron plus 3 and which produces the colored complex, that is red colored complex. Okay, just observe it. Now the medium should be acidic to avoid formation of iron hydroxide in this volhard method. Okay, so this is important point we need to note down. So if silver halide is less soluble, then so silver thiocyanate, as in the case of I minus and Br minus ions, the excess silver plus can be titrated in the presence of silver halide precipitate. Okay, but in this case of silver chloride, when thiocyanate ion is added just after the equivalent point, the following reaction will take place. Okay, so this means that HCN minus, instead of reacting with the indicator, it will react with silver chloride precipitate. Okay, right. We have two ways to overcome this problem like this. And the first one is, the first includes addition of some organic solvent which is heavier and immiscible with water, such as nitrobenzene or chloroform, which covers silver chloride precipitate in the bottom of conical flask. Okay, so this is the first solution we can use, and seals it from the aqueous medium which contains excess of silver plus that can be titrated with SCN minus. And the second procedure involves filtration of the precipitate directly after precipitation, and which protects the precipitate from the coming in contact with the added SCN minus solution and titrating the excess silver plus in the filtrate. Okay, right, just look at all these important points. Now, so just check the complete precipitation titration through the Volhard method, so we can come across these important points. Before endpoint, addition of SCN minus ion, then there is a formation of silver thiocyanate precipitate. Okay, and in that case we can observe faint yellow color, and at the end point all silver plus ions completely consumed and excess SCN minus react with Fe plus 3. Okay, and ferric ammonium sulfate indicator here show slight orange or red color, and after end point further formation of ferric thiocyanate, so that means excess Fe plus react with SCN minus to produce more ferric thiocyanate, and which gives strong dark red color. Okay, right. Next one, advantages of Volhard method. The acidic environment gives advantage for halide analysis because anions such as carbonate, oxalate and arsenate that do not form precipitate with silver in acidic medium, but they do in basic medium. That's why here in Volhard method acidic medium is using, that's why, so it is well to use for these ions. Okay, right, and give accurate result due to batch titration which we are using in Volhard method, indirect method. Okay, right. Limitations of Volhard method: cannot be used in neutral or simply basic medium. Only it should be used in acidic environment, and it takes time. So that is simply time consuming process. And next one is Fajan's method. So here fluorescein and its derivatives are adsorbed to the surface of colloidal silver chloride. So the main point in Fajan's method is adsorption. Okay, so the fluorescein and its derivatives adsorbed to surface of colloidal silver chloride, and after all chloride is used, the first drop of silver plus will react with fluorescein and forming reddish color. Okay, so since fluorescein and its derivatives are weak acids, the pH of the solution should be slightly alkaline to keep the indicator in anionic form. It is important sentence, just note down. But at the same time is not alkaline enough to convert silver plus into silver hydroxide. So the medium should be alkaline, but it is not high in alkaline nature. If it is high in alkaline nature, then silver plus ions converted into silver hydroxide. So this is unwanted. So the medium should be alkaline, that is slight alkaline only. Okay, fluorescein derivatives that are stronger acids than fluorescein like eosin can be used at acidic pH without problems. Okay, so this method is simple and results obtained are reproducible. Okay, now before endpoint, adding of silver plus ions to Cl minus ions and formation of silver chloride. At the end point, all silver plus ions are consumed, and after the end point, anion dies. Here we are using fluorescein and its derivatives. So simply here we call them as adsorption indicators, or adsorbed on silver chloride surface. So excess silver plus react with fluorescein, producing reddish precipitate. Okay, right. Now applications of precipitation methods. So the first one here we can give determination of chlorine in natural water by Mohr's method and by just using Mohr's method and Volhard's method. And second one we can say determination of silver in silver alloy by Volhard method. And third one we can say determination of halogen in organic compounds like food and organopesticides by just using Volhard's method. And fourth one here we can give precipitation titrations have best applications when titration is not recognized by color changes. And next one, precipitation titration is amperometric titration in which the potential of suitable indicator measured during the titration. Okay, right, and thank you very much. Guys, if you are interested, just visit chemmasters.online website or download mobile app CHEMMaster from Google Play Store to join standard courses with test series to get guaranteed success in various competitive examinations like CSIR, GATE, JAM, and all other chemistry competitive examinations. Thank you very much.